The function map allows us to change each element within some sequence by a given transformation. Most JavaScript developers encounter map as part of the array object itself. If we imagine that we have an array of 1, 2, and 3, and let's also say that we have a function, and we'll start very simple, called add1, that takes a number, adds 1 to it, and then returns the result. There's actually a method on the array instance array called map, which we can pass a function to, which will give us a new array. And if we log our result, we'll see that we'll get 2, 3, and 4. This makes sense because add1 was called for each element in the collection. You can actually pass map anonymous functions. So in this example, we just simply replace it with a inline anonymous function of x plus 1, and we'd get the same result. So what's kind of happening here? One good way to understand this is to take a look at a custom class that we write. And we'll call our class triplet, and it will take A, B, and C, and then store those values internally. We're then going to write our own map method on this class. It'll take some transformation, which is really just a function, and then it will apply that transformation to each element, A, B, and C, and return a new result, which is a new triplet. This example sort of shows us what's happening internally when we call map on an array. It's really going through its internal collection and calling that transformation on each element. If we were to use this, we could create a new instance of our triplet with 1, 2, and 3. And then if we were to, let's say, store an updated triplet by calling our map method and then passing it x plus 1 as an anonymous function, and then log the result, we would get a new triplet that would have, I believe, A as 2, B as 3, and C as 4. This is a good way to try and understand what does it mean when we talk about a method form of map. It's really just some collection that has a map method. But there's also another form of map, and it's a very common one, and that's really what we call the function form or the freestanding form of map. And in this one, instead of having our object know its internal data, we pass that object to a function. So in this case, we take a transform, which is a function for transformation, and we'll start off with an array. We'll create a result object to hold our information, and then all we'll do is iterate over that array, transforming each element and push it onto our result. We'd call map, we'd give it a function, and then pass it 1, 2, and 3. And if we were to log the result, again, we would just see 2, 3, and 4. Again, same work is being done, it's just a free-floating function rather than being attached to some instance of an object. We can actually do some things here to enhance map a little bit. And one thing is we can, instead of just confining ourselves to only taking arrays, we could take any kind of iterable object in JavaScript. And I won't go into the iterator and iterable protocol, but what we can do is we can rewrite our function or refactor it slightly just by changing the way we iterate. And if you take a look here, look at how we do the iteration above and below. The syntax below allows us to iterate over anything that is iterable. So what does this get us? And why is this version of map maybe a little bit better? Well, let's imagine we have something that isn't an array, okay, and we still want to map over it and return a new list of some data type. In this example, we'll create a lazy incrementer that will increment up to some number, but only when it gets called or is asked for the next value. And don't worry too much here about the JavaScript's iterator or iterable protocol. We're just going to show that what we'll do is on each iteration, we'll call next, it'll determine if it's reached the limit, and it'll also pass the current value. And this basically will act as a way of creating a series of numbers without actually having to hold them in memory until the point at which they're needed. So we'll use our map function, which now takes anything that is iterable, and this time we'll pass it our lazy incrementer with 5, our same add 1 as our transformation. And if we were to then log the result, we'd see that we'd get 2, 3, 4, 5, and 6. It might take you a minute to see why that is, but it's definitely something that is incredibly powerful. We've expanded what map can do. It can take any kind of iterable sequence and return a new array. I want to go over one more thing here, which is a curried enhancement or a curried form of map, which you'll see somewhat frequently. What we do here is instead of taking transform and iterable, we take transform and then immediately return another function that takes iterable. And I'll highlight that so you can see it here. Check out those two areas. It's a slight difference. The rest of the function is the same. But what does that slight difference get us? What advantages can we kind of reap from it? Well, one thing is we're now able to make new functions from map by just passing it a single transformation. So we now have an add one to each function, and we'll also create a have each function. With these new functions, we can then create some results. And for the first one, we'll add one to a list of just 1, 2, and 3 in a simple array. But what's interesting is because our map can take basically anything iterable, we can call have each with our lazy incrementer with, let's say, 2. If we then log the results of both result 1 and result 2, we'll see that what we basically get here is 2, 3, and 4, which we expect, and 0.5 and 1. It's definitely something to take a look at and be familiar with. It can be incredibly helpful. Don't feel the need to write all your own map functions. They are existing in Lodash and Ramda. Please remember to subscribe. We're going to give out free merchandise to one subscriber every month.